Hello everyone, welcome to our last day here, the third day. We will start this day here in Tesla with a talk about AttackMate, modern open source tool for automating cyber attacks by Wolfgang. Enjoy it.
So good morning, and nice to have you here that early. I'm talking about the tool that I basically wrote. So most of the code is from me, and and I hope some of you will find it useful. So basically, my hidden agenda is to find someone here who is interested in this tool and tries it out because it's free, it's open source, and I just try to give you an impression what it is. I won't show you all the details, and it's not a list of features. I just want to give you an idea about the design and about possible use cases for that tool. At the end, we also have a demo. It will be a short movie where I recorded one run with a more or less interested or pretty interested use case and a nice scenario. But before I start with the demo later, I will also show you and guide you through all the attack steps, because otherwise it might be a little bit confusing. So I'm Wolfgang Hotwagner. I'm working at the AIT, Austrian Institute of Technology. It's one of the biggest non-university research centers in Austria, and we do different things, but in my department we focus on cybersecurity somehow. So we have a lot of different teams with crypto lords and physical guys and stuff like that, and in my small team we are focusing on log data anomaly. So we create test beds, we simulate environments, then we automatically attack those environments and infrastructure. We collect all the logs, and then the real work starts, and we try to figure out new ways to find anomalies in systems. All the research is also open source, so if you are interested, just ask me, because I don't have a link for that. But out of this, we had the need for some automation tool. And that's also why I'm explaining that all, because that's the background of that tool. So you might think there are already a lot of tools, and those are some of them. Some are specifically research tools, others are red team automation stuff, others are more likely to simulate things, but I tested a lot, I tried a lot, but they were not sufficient for our use case. And that's why I started to figure out all the requirements that we need in our research. All the tools that are out there focus very much on when is where what executed or attacked. But for us in our research, the how is a very fundamental part. Because if you think of let's say, Linux privilege escalation, that can be executed in many different ways. And all those different ways manifest differently on the systems. So the log files of a privilege escalation of an exploit might be very different than, let's say, misconfiguration of a sudo. And we also want to vary, and we also want to create easily create some attack chains. So the how is the target exploited and how is the attack chain executed is for us essential. And we don't want to have like a simulation. We really want to have real tools with real attacks, and we want to have a framework, and if it's possible, not too complicated. What are the different application areas? It's not just a research tool. in our department, we also have like a cyber range for trainings where companies and other people are training specific cybersecurity stuff. And also here, an automatically a tool that automatically attacks stuff can be very, very interesting for trainings. For example, just think about you execute the tool, and depending on how the blue team reacts, it changes its behavior, for example. That's possible with this tool. And also for pen testing. If you have like boring stuff like information gathering and you do all the time very similar steps, you can automate this and do it overnight or something like. Yeah. So what are the design principles? Because I told you I don't want to list up all the features, but I want to give you an idea what we are focused on and what this tool is. So for me, it was very important to have a reproducible attack chain. Why? The last couple of years I was in projects where I had this README file, MD, with all the commands, and I copy-paste it all the time. And I mean, in this project, I had to copy-paste it like 30 times or something like that. This was like, I need something else. That's where this idea was born. And I also want to have a portable attack chain. So I want to give you a playbook and you execute it on your environment, and it will do exactly the same, even if the environment differs in some way. So we also focused on that, and I will show you later how we did this. And it should be developer friendly, but what means developer friendly? I mean, it means that if you are someone who can execute an attack chain manually, then it should be an easy task for you to use this. So you don't have to be some sort of programmer or something like that. Managed exploits, I mean, that one was easy. We use Metasploit for many things. So we have the metadata, and we can search the exploits and file it and something like that. Also perform known attacks with Metasploit, but also any GitHub exploit we can use. Use common malware. If you think of, or does anybody use Caldera from Mitre? Nobody? No? Okay. Caldera, for example, you have to install an artificial agent. And the agent executes all those attacks. And we didn't want to have an artificial agent. We want to have like the real deal, and like Cobalt Strike or something like that. I mean, Cobalt Strike doesn't have an API, so a little bit difficult with Cobalt Strike. But we found, for example, Sliver. If you know Sliver, it's Cobalt Strike-ish open source software for command and control. And this one has an API. So we use common malware that also some attackers are using. And we want to have customizable attack chain elements. So I just told you that privilege escalation can be executed in different ways. We also want to be able to execute them in a row, like in a sequence, and try this one, then that one, and collect all the logs. And it should be usable for every phase of the kill chain. So when you think about lateral movement, go from one host to the other one, you have special requirements like port forwarding. You need port forwarding to execute some exploits on the target machine or something like that. That's also possible with AttackMate so far. The general concept is AttackMate has a playbook. The playbook is basically a list of some commands. I come to the commands later. And the commands are sent to the executors, which are built in AttackMate, of course. And those are executing the attacks or commands. If you know Ansible, its playbooks are written in YAML. And I very much designed it very similar to Ansible. So we have the var section on top where we can put some variables, and we have the command section with list of commands. And if you look at the second command, you can see we can even parse the output. So we integrated this Unix philosophy where you can take the output of one command as an input for the other command. And that makes it more powerful because you can mix up different commands in all the ways I didn't think about it. Yeah, in this example, we are parsing the output of a brute forcer, get all the passwords, and then use the password in the SSH command. Another thing is, and all of you who know Ansible, is include tasks. So we can separate some stuff in separate YAML files and then include those YAML files. That's basically like functions in programming, because you have like your function block, which is the YAML file. You have some input variables and you get output variables. So when you call it from the main YAML file, you execute it with some input variables and you get the output and can work with the output. And this helps you to sort some things. If you think about upgrading a shell, you have a reverse shell and you want to have a fully interactive reverse shell so that you can execute Vim or something, then this task is always the same. And this you can put into a separate file, and when you need it, just load that file and you don't have to rewrite that code. And another cool feature, and that's the only really technical thing I really want to introduce you here, is interactive sessions. So on this diagram, we have the user, we have AttackMate, the built-in shell executor, for example, that executes shell commands, which are basically just shell processes. And if you look at the very first command, the process is up and running until the end of the whole playbook. The second command, for example, is simply one command output and it closes. And why do we need this, that the command stays online? We can now create like sessions with create session and a session name, and we can reuse the session whenever we need. For example, for shell commands, we can open up Vim, do anything else, and come back to the Vim and type into Vim. And that's the interactive part that I integrated, because I just told you that I really want to have like realistic logs. And what does realistic logs mean? For us in science, we have to describe what realistic means. And for us, it should look like as a human being was executing the attack. And therefore, we don't want to have like search and replace with any bash command. We really want to have the opportunity to open Vim, type something in, maybe even slow, and save it and go on. Because many human attackers would do exactly this. And we want to be able to do this. Another thing is interactive sessions could also be like SSH sessions. So if you think about SSH, we execute an SSH command, but we want not to close the connection, but reuse the connection. Why is this important? Because if we execute the command in separate sessions, you would have like logins, a lot of logins in the logs, and that's also not really realistic. And yeah, therefore we came up with first sessions so that we can reuse the sessions. And the other thing is interactive sessions. So we can keep up opening those sessions and type anything in. So we are almost at demo time. But before I start with the demo, I want to explain what you will see later. Because later you will just see the output of AttackMate, and this could be a little bit confusing. So let's go through it step by step. So we have AttackMate with all the commands in the playbook, and the first command is a shell command. So we start an nmap scan on our target. Does anybody know SoundMinder? One? Did anybody attend a CTF where SoundMinder was the target?
Actually, yesterday we had a challenge that was SoundMinder.
Ah, yeah. Okay. I think last year there was a CTF, an awesome CTF, and the target was SoundMinder, this open source video surveillance system. And normally at CTFs we think about artificial stuff, somehow put some credentials, anything like an artificial attack surface. But the people who did the CTF were more like, no, hack it. Find the 0 day to get in. And there were like 10 or 20 CDs after this challenge. And one of it was a command execution in SoundMinder, unauthenticated. And yeah, I wrote an exploit for that. And I uploaded it to Metasploit. So if you check out the official Metasploit repository, you will find my exploit. It's called SoundMinder Snapshots. So, but we now are at the very first beginning. We scan the host. And after scanning the host, we exploit, of course, our Metasploit exploit to get foothold. After gaining the foothold, we have like a reverse shell, and now we want to escalate the privileges somehow. And in our demo, we use a misconfigured sudo. And this is also something where the interactive mode comes very handy, because we can, sudo is configured to, the web user is able to execute dmask to show kernel logs. And dmask has an option for human mode, and this human mode starts a pager, which is interactive. You can scroll, and that's nice for humans. But you can also escape, and then you are root. And for that, the interactive mode is very handy. We will see that later, maybe. So after we have privilege escalation succeeded, and we have everything in place with all the permissions, we start to install a backdoor. And for that, AttackMate can launch a web server automatically and serve the binary or serve the payload, which also comes very handy for attack chains to load something from external. And the backdoor is basically a PAM Unix backdoor, which has a hard-coded credentials inside. So after that, we can use the hard-coded credentials to log in via SSH. And that's what we do now. We log in with the hard-coded credentials, because now we have our backdoor persisted, and we can simply log in via SSH. This step would not be, it is not really necessary for an attack chain, but I want to show you something. So, and then we install the malware. And our malware, as I told you before, is a sliver implant. So AttackMate can generate a sliver implant for you. If you know Cobalt Strike or any C2 systems, normally you generate the payloads, and then you have like obfuscated stuff and hidden stuff and so on in the binary, and then you put the binary on the machine. Once the malware is executed on the system, then it connects back to the C2 server. In our case, I think it is a DNS-based connection, but Sliver has a lot of like WireGuard and HTTPS and so on. And AttackMate can even create sessions for the Sliver connection. So after that, we can use the Sliver connection to do other stuff over the Sliver connection. And that's what we do, actually, because we also have a built-in rootkit, LD preload rootkit in AttackMate, which you can also simply generate and create the binary and serve. And then we install the rootkit to hide the malware, because we don't want to have the process listed, and we don't want to have the network connections and the user and stuff. And that's what the rootkit does. It also gives you an opportunity to have like a privilege escalation. So, yeah. And now it's demo time. I think it's big enough. As you can see over there, we have Have It Your Way as our credentials. We try it out at the very first beginning to see that these credentials won't work because it's not backdoored yet, the target. So permissions denied. The backdoor user does not work yet.
To the microphones.
Oh yeah, sorry. So now we start AttackMate with our playbook. Oh yeah, thank you. We start AttackMate with our playbook, and what we can see here is general output, like what is executed in general. We don't see the output of the commands. Those are logged in a different log file, but we can at least see what's executed, and everything we see here is also automatically logged in a different log file. We need this very much for the log data anomalies because we create data sets, and it's very nice to know when the attack started and stopped for data sets in order to label the data sets, for example. And yes, this exploit takes a while because it also has to create the reverse shell and test if it's exploitable. But in the meantime, I can tell you about the new feature we added. It's, we can also create some metadata, so we can tag and label everything. So now you can see that we are upgrading the shell to have a fully interactive shell. And then we also see the privilege escalation right here, which is interactive, as I told you. And after that, we have the web server started, and we serve the backdoor. And now we generate the implant for the sliver implant. And as soon as the sliver implant is generated, we start the listener for that. And now we have to persist it. We want to persist the malware, and we use a systemd service for that. And here you can see that we can start Vim interactively and really type in every Vim stuff. You can see all the Vim commands I'm executing now here to persist the sliver malware. This takes a while because Vim is in interactive mode and it doesn't return any output. So I have to use some timeouts for that, just to know. So this will also take a while. And we use the group fax because other companies than governments doesn't use the fax group, but the fax group is installed automatically on every Debian system. So we use this fax group, and when you are in the fax group, you can see the rootkit process and the rootkit and the hidden stuff from the rootkit. Yeah. Hopefully nobody used fax on that machine because then. So after that, I mean, here we installed the C2 implant and the malware, and now we are compiling the rootkit to the LD prelude rootkit to hide later the malware activity. And as soon as this is done, it's uploaded and it's installed. We use the father rootkit, which is publicly available on GitHub. Yeah. Now let's check out the logs. As you can see, every step is in the log, and with the new version of AttackMate, you could even have like metadata on the logs for labeling data or something. And the output logs simply puts all the output to the output log of. I mean, I mostly use this log just for debugging. When you start to create an attack chain and something doesn't work, then I check out this log and see what came back. And yeah. This also takes a while because I really didn't want to shorten the video because it's confusing. And yeah, as you can see, we have like the command and control tool. It's called setm controller, but it's sliver. I called it setm controller because all the SoundMinder stuff is called setm something. So make it a little less obvious. And now we can see the root jail stuff because I had to compile the further rootkit. I mean, this is done by AttackMate automatically in the root jail. And therefore, we see all the files that are in such a normal Debian bootstrap. And now, let's test it out if everything worked, because at the beginning, we started with SSH, and our backdoor password did not work, but now it works. And we also checked out if there is any process with ZM controller, which is our malware. And it's supposed to be hidden, and it is hidden. We can just see the process of grep, but not the process of the sliver malware. And we execute gpassvd. This is our privilege escalation tool, but it only works if we are loaded the rootkit. So now we trigger the rootkit, and if we execute gpassvd again, we get root instantly. And now we are in the fax group, very important, the fax group. And from there we can see also the hidden stuff. Yes. And everything we saw now was executed automatically, and we can repeat that. I mean, of course, we have to clean up the servers. So if you have some simulated environment, you then would have to dump the server and create it again. But you can repeat the playbook whenever you need it. And I believe this is awesome. So we have an open source tool to automate those attacks, very Ansible-like. So I want you to really use it. If you find a use case for that, use it. The documentation is pretty well. We documented almost everything, and we are working on it. So we are using it in our research, but also in other teams. And we even had some cyber exercises with this tool. And therefore, we always constantly try to improve it somehow. Now we even have a team for that. So we are not just one person, we are more now. And we really try to make this tool like the tool we need and the tool we would like to have. So it can mimic human behavior. That's for us in research very important, but could also be very nice to see in exercises for blue teams or something. We have a tool that is usable for every phase of the kill chain. I'm not sure about if this tool is very useful for OT environments, but if you know any scenario for OT devices, please let me know. And yeah, it's not just for research and cyber exercises. I think we can also use it for pen testing. I have some things in my mind for future work, like everybody is talking about AI now, right? But AI could also create playbooks, for example. And currently we are working on improving AttackMate so that it is more easier to integrate it into other custom Python programs. So I think with the next version, we could also integrate it easily and use it for attacks and get the response. So we can even put an AI into the response stuff, and it can learn. And of course, it could change its behavior depending on what it comes back from the targets. So if you have any kind of research in your mind, you can use it. It's free open source. Please try it out, and you can contribute with issues, you can contribute with feature requests. I'm very open for everything. Thanks.
Do we have any questions? Okay, thank you.